Hi, welcome to another video on fixed point binary notation. This is another tutorial video where I'll be covering how we represent decimal fractions in binary fixed point. So an example of this could be, say, 1.5 or 2.25. Something like that. Those are some simple examples. What we're going to go through now is how we represent 9.25, slightly more complex example, in fixed point. Now, if you remember back to my previous tutorials, we can represent a 4-bit nibble, 8, 4, 2, 1 in decimal, and that nibble is going to be used to represent our 9 over here. So 9, 8 can go into 9, so we put a 1 in there. 4 can't go into 1, so we put a 0 in there, because 1's left over. 2 can't go into 1, so we put a 0 in there, but 1 can go into 1. So that's how we represent 9 in a 4-bit nibble. Now we've got our decimal point here. Then after the decimal point, to represent the fractional part of the number here, we're going to use the negative powers of 2, so 2 to the power of minus 1, 2 to the power of minus 2, and so forth. So these fractions turn out to be 1 over 2, 1 over 4, and 1 over 8, 1 over 16. So we've got 4 bits on each side. So what we need now is, since 0.25 is equal to 1 over 4, we put a 1 in this column and a 0 in the others. Okay, so if you wanted to represent 9.25 in fixed point binary, you would write 1001.0100. And the question will specify how many bits it wants you to have on this side, because of course for this one I could have just written 1001.01, and that would have been perfectly correct, but usually it will say something like 4 bits on each side. Okay, now let's have a look at a different number. Let's represent 14.5 in fixed point. So I've got my 4-bit nibble here, 8421, and 8 will go into 14, so I'll put a 1 there. 4 will go into the remainder, so I'll put a 1 there. 2 will go into the remainder, and then we've got 0 left over, so 8 plus 4 plus 2 is 14. And then we have a 0 there. Okay, and now this is getting onto the fractional part of the number. Use our negative powers of 2 again. I like to write the fractions, but you can write the decimal equivalents as well. And this time we just need 0.5, which is equal to 1/2. So we just put a 1 in there and a 0 in the rest of them. Okay, moving on to our final example then, I'm going to be showing you how to convert 2.375, so 2.375 to fixed point. Now for the first 4 bits we're going to do exactly the same as we did before, and that's obvious, it's just 2. Just put a 1 in the 2 column because we've only got 2 on the left hand side, so just put 0, 0, 0 in the rest. And then here, because it's 0.375, we're going to require a combination of 2 fractions, and 0.375 is equal to 3 over 8, which is equal to 1/4 plus 1/8. So let's write our fractions on this side: 1/2, 1/4, 1/8, 1/16, and then we're going to put a 0 in the 1/2 column, a 1 in the 1/4 column, a 1 in the 1/8 column, and a 0 in 1/16. So our fixed point binary representation of 2.375 is going to be 0010.0110. Okay? Thanks for watching.